We all know that the Earth is made up of layers. We learned this in school, and it's generally accepted knowledge that our planet is divided into the core, the mantle, and the crust. Scientists have learned a lot about these layers, and yet there are many mysteries surrounding them, especially when it comes to the mantle. So what exactly is down there? Welcome back to the channel. Today, we will take a look at the mantle and find out what lies beneath the Earth's crust. The Earth's mantle. Let's begin with some facts about the mantle. This layer is massive. It makes up around 84% of the planet's volume and extends from the crust to the core. Although it's so large, it's still dwarfed by the core. The mantle is around 2,900 kilometers thick and is almost 3 times the thickness of the crust. Even though the mantle is so thick, it's not easy to study. The only way scientists can learn about its composition is by analyzing the seismic waves generated by earthquakes. By studying how the waves move through the planet, they can get an idea of what the mantle is like. Because of this, we know that the mantle is solid, but it's not like the crust. The mantle is much denser and hotter. Scientists believe that the mantle is divided into 2 layers, the upper mantle and the lower mantle. These layers aren't divided by anything physical, but by the speed at which seismic waves move through them. The upper mantle has a depth of around 700 kilometers, and the lower mantle reaches the core at around 2,900 kilometers. The temperature in the upper mantle ranges between 700 degrees Celsius and 3,700 degrees Celsius. As you can imagine, things get pretty hot down there. If you want to see the mantle for yourself, you won't be able to do it at any temperature. You would have to travel deep into the Earth to see it. To reach the upper mantle, you would need to drill a hole more than 10 times deeper than the deepest hole humans have ever dug. Our deepest hole, the Kolyma Super Deep Borehole in northwest Russia, is just 12 kilometers deep, while the shallowest part of the upper mantle is 70 kilometers beneath the surface. The lower mantle, on the other hand, is even hotter. Temperatures range between 3,700 degrees Celsius and the scorching 5,700 degrees Celsius at the boundary with the core. Despite the high temperatures, the mantle is still solid, although it does get softer and more flexible the deeper you go. That's why it's sometimes called the Earth's plastic. This malleability enables the slow churning of the mantle, a process known as convection currents. Convection currents are the driving force behind the movement of the Earth's tectonic plates. These plates make up the lithosphere, which includes both the crust and the uppermost part of the mantle. Hotter material from the lower mantle rises up, while cooler material from the upper mantle sinks. This constant motion has a profound effect on life on Earth. Volcanoes, earthquakes, and mountain chains are all results of the dynamic forces unleashed by the mantle. In fact, the energy released by the mantle accounts for most of the heat that reaches the Earth's surface. What's in the mantle? Now that you know more about the mantle, let's find out what's inside it. Unfortunately, we don't know exactly what's going on down there because no human has ever been to the mantle. But scientists were able to come up with a pretty good idea by analyzing the seismic waves we mentioned earlier. They also used X-ray technology to scan through the mantle and get an idea of what's inside. Scientists discovered that the mantle is mostly made up of silicate rocks, the same kind of rock that makes up the Earth's crust. However, the minerals present in the mantle differ from those found in the crust. Some of the minerals are only found in the mantle, and others aren't found anywhere else. One of the most abundant minerals in the mantle is olivine, a mineral that is commonly found in green, but it's usually colorless in the mantle. Olivine is a magnesium-iron silicate that is formed under high pressure and high temperatures. It's so common in the mantle that it makes up 45% of its mass. And even if you're not interested in minerals, you should know that the mantle also contains plenty of metals. Iron and magnesium are probably the most abundant elements in the upper mantle, but silicon, oxygen, and calcium are also present in significant amounts. Nickel, aluminum, sodium, and potassium are also present in the mantle, although in smaller quantities. Iron sulfide is also present and is thought to make up around 3% of the mantle. The lower mantle, on the other hand, has different proportions of elements. For example, iron is less present than in the upper mantle, while aluminum and calcium are more present. These minerals and elements are arranged differently in the mantle. In the upper mantle, minerals tend to form separate layers depending on their density. For example, olivine crystals are located at the top of the layer, while denser minerals such as pyroxene and garnet are located at the bottom. As you go deeper, the minerals turn into a dense, hot, hard rock known as peridotite. Peridotite is made up of olivine and pyroxene and is believed to be the main rock in the upper mantle. Below the upper mantle lies the transition zone, where the minerals rearrange themselves. At this point, you'd be met with high pressures and temperatures. And here the minerals transform. The most abundant mineral in this zone is ringwoodite. Ringwoodite is a form of olivine that is stable under high pressures and temperatures. It forms around 410 to 660 kilometers beneath the surface. As you continue your journey down, you will find the lower mantle. This part of the mantle is a lot more uniform than the upper part. Minerals in the lower mantle are packed tightly together, and scientists believe that it's made up of a single super rock called D that marks the boundary between the mantle and the core. Here, you'll find Bridgmanite and post-perovskite. Bridgmanite is named after the American physicist and Nobel laureate Paul Bridgman. It's one of the most abundant minerals in the lower mantle, and it's only found at such depths. On the other hand, post-perovskite is rarer and was only discovered in 2014. These minerals show us that the mantle isn't just a dull place. There's a lot happening below the surface of the Earth, and we've barely scratched the surface. The mysteries of the mantle. As we mentioned earlier, the mantle is one of the most mysterious parts of the Earth. We've managed to collect data about it, but it's still a relatively unknown part of the planet. This is mainly due to the difficulties in studying it. Scientists use seismic waves to study the mantle, but there's a problem with that. Seismic waves can't tell us what's inside the mantle. They can only tell us what the mantle is like. This means that we don't know what minerals or elements are in the mantle, only how fast seismic waves move through it. This is why the interior of the mantle is often referred to as a black hole in the scientific community. Another problem is that the mantle doesn't give us any surface samples. To take a sample from the mantle would require drilling thousands of kilometers through the Earth, something that's currently impossible to do. These challenges have left us with many questions about the mantle. For example, scientists still haven't been able to confirm the presence of a mineral called calcium sulfate, even though it could help explain why seismic waves travel through the mantle the way they do. Another big question is whether water is present in the mantle. Scientists think it is, but they haven't been able to prove it yet. This is important because water could affect the way seismic waves move through the mantle. It could also affect the way the mantle interacts with the crust, which could help explain things like volcanoes and earthquakes. Finally, one of the biggest mysteries surrounding the mantle is what's at the boundary with the core. We know that the mantle ends at around 2,900 kilometers beneath the surface, and that the core begins there. But we don't know exactly what's at the boundary between the two. Is it a sharp boundary or a gradual transition? What's the chemical composition of this boundary? And what happens to the minerals and elements at this boundary? These are just a few of the questions that scientists are trying to answer. Do you know of any other unsolved mysteries of the mantle? Let us know in the comments below, and thank you for watching.